cycle started, the ALB should be enabled. Okay, for example, this is opcode fetch. If you're adding extra read means you have to read the concept, the latch will be enabled. That is ALE will be enabled for the every machine cycle. Then this is the condition. This condition written from the previous table. Okay, opcode fetch means what we did. That is, we need to select the memory. Then we need to define the S1 and S0 value. So we need to select the memory means you have to put 0. If you are selecting the opcode fetch means you have to put 1 1. Okay, this is the concept here. They are written. Then opcode fetch is a read process. Okay, so read process will enabled when opcode is enabled. That is the concept. When read enabled, the opcode will be loaded into the address and the data bus. Got it. So this is the concept. That is, when RD is equal to low, then only we can fetch the data from memory. That is a read concept. So that what's explained in this cycle. This is the memory read cycle. Okay, in memory read cycle, same clock pulse same, address same, and address lower address bus same, ALE same. Here memory read already is told that we are selecting the memory. For read cycle it will be 1 0. Okay, for write cycle it will be 0 1. That is 10. So read enabled in the second and third state. So that time only we can get the data. Memory write cycle. So this is the clock pulses. So same AD15, AD0 to AD7, ALE. So you are selecting 0 1 and memory. Then write operation because it is a memory write. So when write, then only this data will be loaded into the address and data bus. Okay, got it? Input output read. So yeah, all the machine cycles are same concept. Okay, clock pulses AD0 to AD15. So ALE input output read same. Here only the status will change it from change. Input output raise cycle. Here they are using port address for input output operation. They are not using the data address like that. They are using port address. So AD15 is a port address. So AD072 port address and data. ALE. So write then input output operations like that we can define. Okay, let's see a example for timing diagram. Okay, in university exam they will ask sketch the timing diagram for STA526A instruction in 8085 microprocessor like that they ask them. Okay, first you need to know so how many bytes it is required. So already we said so already I said that is 3 types of instructions are there. Okay, so when we see the STA526A, we know that it is a 3-byte instruction because it is having 16-bit value in the operand. So it is a 3-byte instruction. First you have to write the 3-bit instruction opcode value. Sometimes they give the opcode in the problems. Otherwise you can put some values for opcode. Okay, so that is STA526A. So opcode for STA will be 32. Then remaining value 526A. That is you have to write reverse in the 8085. About 526A means you have to write first 6A then 52. So this is the concept. Okay, then how many read and write and opcode fetch cycles will be required? We need to know because STA means store accumulator value to the particular memory location. Okay, that means we need to opcode fetch. Opcode fetch. So we need to define the opcode. When read memory because we are going to read the two types because we have 16 bit, so we need to two types of values, then write. Okay, then write the value. So a value should write into the memory, that is particular memory. This is the concept. So if we know these values, so what are the machine cycles used means if we know it is a simple operation. Okay, if you know this how many of generally there will be a opcode fetch cycle will be 1. Then how many is read state, how many write state you have to know. Okay, depend on the instruction size, instruction. Okay, so opcode fetch 40 state, memory read 3, again memory read 3, then memory write. Okay, let's see the timing diagram. Okay, here see the STA timing diagram. First they put opcode fetch 4 cycle, then memory read 3 cycle, and memory write read 3 cycle, then memory write 3 cycles. Totally there are 13 T state. This is the time required for instruction, time required for instruction execution. Okay, so got it. So that is clock pulses. So totally we required 13 clock pulses, then AD0 and AD7 value. Okay, so that is every clock pulse. First one is opcode is 32. Next read cycle of 68. Next read cycle of 52. Then write the value C7. So C7, which is A7 A data, because we are storing the accumulator value into the memory. Okay, so C7 is a accumulator value. Then AD8 to AD15, so that is address. Okay, this is the address. So 41, 42, 42, because it is the address. So first we did some one now, that is address 41, 42, 42. Okay, so that 52 will be the final output address. Okay, okay. So then ALE, so already we told that ALE have to enable for the every first hour. Okay, sorry, every first machine cycle. So machine cycle every time. So you see that every first clock cycle, first machine cycle will be enabled. Okay, then read low, here read low, here read, because in opcode we are reading the opcode, then in memory read we are reading the memory, again memory read we are reading, but in the memory read will be 1, that is the 1 means it will read will be disabled. So same in memory write only we are enable the write. So remaining values are 1. So this value will be 0 because active low condition. Same as input output signals. For output fetch it will be 0 1 1. For memory read it will be 0 0 1. For memory read again 0 0 1. For memory read it will be 0 1 0. This is written from the table from. Okay, this is the concept. Next, so timing diagram of INCO. This is the example for input output read and input output write cycle. That is, we are fetching the data from some memory. So this is a opcode fetch, memory read, and the input output read. Okay, that is we are in means we are reading the data from the input output device. For example, if we are connecting the switches with the microprocessor, means for a particular switch we can get the status whether it is 0 or 1, like that we can read the data. That is 4125 and 4126. It is a 2-byte instruction, so we are defining the 2 input values. Okay, this is the timing diagram. Okay, machine cycle 1, machine cycle 2, 3. First one is opcode, second one is memory read, and final one means input output read. Okay, then clock pulses, then AD to 15, then AD0 to AD7, ALE already told that is read. So finally write. So finally input output read. This is the concept. So we have in another different kind of timing diagrams like this. So this is the 8085 timing diagram. So simple concept, that is graphical representation of execution of instruction, that is in timing diagram. Okay, it is done by the okay, so it is done by the different cycles. Mainly we have to know what are the cycles available. So what is instruction cycle? So what is machine cycle? And what is the state, like that we can define. You got it? Okay. So next class we will see the 8051. So this up to this it is a 8085. It is a microprocessor. So next class we will see the microcontroller. First we need to know, so what is the difference between microcontroller and microprocessor. Okay, so like that we will discuss in the next class. Okay, thank you. We will see in the next class.